Hello, welcome to Cleekly. Today we'll introduce gathering quests in the game. Gathering quests are a very common mechanism in games, with counting as the core, such as killing a certain number of monsters, collecting a certain number of gems, finding a certain number of props, and so on. When counting, we use integer or float as the core data type. For example, if the quest requires killing 5 monsters, then the number 5 is the key data. When the number of monsters killed reaches 5, the quest is completed. Let's see what game effect we will achieve at the end of this tutorial. Rem encounters a mysterious stone forest ruins during an expedition. To enter the ruins, she must complete 3 quests. The fighting power test, which needs to cause a total of 1,000 damage points. The fitness test, which needs to collect 5 magic stones, and the final test, which needs to complete the above 2 quests to get the extra rewards. Rem bravely accepts these 3 quests and completes them successfully. At this time, the gate of the ruins open, and it turns out that fighting power and fitness are the qualities that must be possessed to enter the ruins. First, let's do a quick breakdown of the project. We set up 3 areas for the players to take the quests. When the player enters a specific area, their corresponding quest UI will pop up. In this tutorial, we will focus on the logical implementation of the counting, so we won't introduce the UI design in detail. When the player enters Quest 1 area, the system will count the damage the player caused to the enemies. If the accumulated damage reaches 1,000 points, Quest 1 will be completed. When the player enters Quest 2 area, every time an enemy is killed, a magic stone will be dropped. If the player collects 5 magic stones in total, Quest 2 will be completed. If both Quest 1 and Quest 2 are successfully completed, then Quest 3 will be completed automatically. According to our needs, we can break down the project into 3 parts. Quest 1, Fighting Power Test. Quest 2, Fitness Test. Quest 3, Final Test. Now, let's see how to achieve these functions. Whether it is Quest 1, Quest 2, or Quest 3, they all have 3 states, namely, Quest Not Started, Quest Started, and Quest Completed. We can define an integer attribute for each quest, where 0 indicates that the quest has not started, 1 indicates that the quest is in progress, and 2 indicates that the quest is completed. For example, we can create 3 items to represent 3 quests. For each quest, add a custom attribute, state, of type integer, and the initial value to be 0. Indicating that the quest has not started. This custom attribute is a custom key value, a special global variable composed of an index, that is a key, and the corresponding value. In our case, the attribute name state is the index, the key, and 0, 1, 2 are the values. We also need to do some initialization settings. Set a global variable unitPlayer of type unit to store the player unit. To prevent players from selecting other units by mistake, we disable mouse click selection and mouse drag selection, and make the player select unitPlayer. Then, we hide the 3 quest UIs from the player. The UI will only pop up when the quests are triggered. Now, let's look at Quest 1, the Fighting Power Test. Quest 1 needs to count whether the cumulative damage value of the player to the enemy reaches 1,000. So, we need to check if the enemy is the unit taking damage, and if the player is the unit dealing the damage. First, we add a new trigger. The event is Receive Damage. Then, set 2 local unit variables to represent the unit taking damage and the unit dealing damage. We also need to set an integer variable, int damage, to store the damage value. Then, we need to check whether the unit that deals the damage is the player unit. If it is true, we accumulate the amount of damage the player unit has dealt to the enemies. If it is false, we do nothing. We also need to check whether the player has triggered Quest 1. When any unit enters Area 1, we check whether the unit is the player unit, and whether the value of key state is 0. That is, whether the quest is in the not started state. If both conditions are met, it indicates that the player has taken Quest 1. We change the state of Quest 1 to be Quest started. Then, we display the panel of Quest 1 and prompt 0 out of 1,000 in the panel to the player. Set an integer variable number to store the accumulated damage value. Use a timer to monitor the accumulated damage value in real time. If the number is less than 1,000, it means the quest is not completed. We continue to accumulate the value of number. Reset the damage value to 0 so that the next new damage value can be stored and accumulated. For the player's convenience to see the progress of Quest 1, we can display the accumulated damage value in the quest panel. Set the prompt text in the panel as number out of 1,000. Remember to convert the integer variable number to string, and then concatenate it with the rest of the string. If it is false, it indicates that the quest is completed. We remove the timer, change the value of state to be 2, and set the prompt text as quest completed. In this part, we use loops for real-time monitoring and selections for condition judgment. Part 2 is about the fitness test. This quest requires the player to collect 5 magic stones. Every time an enemy is killed, a magic stone will be dropped. In this part, we also need to check whether the player has taken the quest. The logic is the same as Quest 1. The difference is that in this quest, we set the prompt text as 0 out of 5, because the quest requires to collect 5 magic stones. Then, we set a variable number to store the quantity of magic stones collected. Use timer and if condition to check whether the number is less than 5 in real time. If it is true, it means that the quest is not completed. We loop 6 times to search the 6 slots in the inventory, to check whether the item collected is the magic stone. If the item in the inventory is the magic stone, we increase the number by 1 and delete the item. For the player's convenience to see the progress, we set the prompt text on the panel as number out of 5. If the number is not less than 5, it means the quest is completed. We remove the timer, change the value of state to be 2, and set the prompt text as quest completed. Quest 2 is done. The last part is Quest 3, the final test. If both Quest 1 and Quest 2 are successfully completed, then Quest 3 will be completed automatically, and Rem will get the extra reward. This part is the same as before. After confirming that the player has taken Quest 3, we use a timer to monitor 2 key variables continuously, which are the 2 local variables int_quest and int_completed we created. The variable int_quest represents the number of quests triggered. The variable int completed represents the number of quests completed. The initial values of them are 0. Then, we check whether the value of key state for quest 1 is greater than or equal to 1. If it is true, it indicates that quest 1 is already taken or completed. We increase int quest by 1. Then, we continue to check whether the value is greater than or equal to 2. If it is true, it means quest 1 is completed. We increase int completed by 1. Repeat the steps to check the value of key state for quest 2. The logic is the same. Now, the variables int quest and int completed can show the number of quests triggered and quests completed in real time. After that, we set the prompt text as int completed out of int quest to allow the players to be able to monitor the whole progress. Lastly, we check whether the number of completed quests is equal to 2. If it is true, it means that both quest 1 and quest 2 have been completed, so the quest is also completed. We remove the timer, change the value of state for quest 3 to be 2, and set the prompt text as quest completed. Quest 3 is done. It's all set. Let's test the effect. Now, it's time to review what we learned today. Today, we introduced the game mechanism of gathering quests. Gathering quests are very common in games, with counting as the core. Then, we analyzed the logic of 3 different gathering quests. We also introduced the use of custom key values. The core data type we use to count today is integer. We monitor these data to determine whether the quest is completed. This can be used in various game mechanisms, such as the determination of global achievements in the game, the limit of the number of characters' lives, and the setting of magazines in FPS games. Thanks for watching. See you next time.